Hello, we're going to do chapter 11 reading homework, problem number 2, the one with this beautiful clock over here. This problem's a lot easier than it looks. It looks a little dreadful at first, and you're kind of like, oh my gosh, like how am I going to calculate all this? It's really not that difficult. Once we lay out some simple formulas, it's actually pretty easy. The main formula. Now remember, we had all our kinematic rotational equations, and the main one that we're going to be using here is theta equals angular velocity times time. Now even just writing that, some of you are going, okay, alright, well now this problem's super easy, and you're totally right. Because we're given time. Time is our constant. In my case it was 36 minutes, and if yours is 36 minutes too, then lucky, because I'm pretty much doing the problem for you. And theta is what we're trying to find out. So theta is in radians, so it gets pretty simple. Now remember, angular velocity is going to be our change in theta over our change in time. So just starting off with part A. Let me change colors here. So part A asks us, okay, through what angle in radians will the second hand turn before the end of class? All right, well first, second hand, first of all, is a little minute hand here, this red one. So it's going to do 60, every 60 seconds it makes that loop. And so what is our angular velocity? Well, first off, something that might throw you off is they are asking for theta in minutes per minute. So if you do seconds, 60 seconds, you're going to get this wrong. So, well, what's our theta? Well, our change in theta is obviously 2 pi, right? For all of these, it's going to be 2 pi. Then for our change in time, well, how many minutes passed? How many minutes would it take for that second hand to do a full rotation? 1. Because it's going to do 60 seconds, then it's going to make the top, 60 seconds, make the top. So 1 minute passes every time that this does a complete loop. So you just put a 1 there. All right, well now, the formula calls for angular velocity times time. So I just plug in 36. Well, I'm done. 2 pi times 36, that's going to get you 226.194. So that's how many radians. And obviously, look back on this and understand it more. If they give us this angle, and they say how many minutes passed, we divide this by 2 pi, and we say, hey, that minute hand went around 36 times. So that's a quick way to figure out. You do this the same with B and C, and I won't do all of them because you guys are getting the pattern here already. But for example, with B, it's 2 pi over what? Well, let's see here. The minute hand. How many minutes is it going to take for it to make a full rotation? Well, 60 minutes, because every minute I know it's moving 1/60th, and so after 1 hour, or 60 minutes, it's going to make a complete 2 pi revolution. So I do it by 60. I multiply that by time, 36. Your answer is going to be, I don't have it written down, but yeah, you're getting the picture here. For C, same thing, except instead of 60, it's going to be what? 60 times 12, right? Because 12 hours have to pass before it makes a complete loop. So if you put it in minutes, you'll get 720. Whoops, I'm moving around all over the place. Let's move back here. So you guys are getting kind of, the main picture of how this is all working out. Now, another big thing for part D and F are pretty, you already found the angular velocity. So really you're just going to plug in just these equations into the answers. Now, G is another one, is the angular acceleration of the second minute in both hour hands the same. Well, now remember what angular acceleration is. Just remember what acceleration is. Are these minute hands speeding up? Are they getting any faster? Well, no. Time doesn't accelerate. Time stays the same. It's constant. There are always going to be 60 seconds in a minute. Nothing's going faster. So it's kind of a trick question. So remember to watch out for that one, that there is no angular acceleration because they're all moving at the same constant velocity. I think I went over that pretty well. If you still have any questions, go ahead and message me on Facebook or something. But this should help out anyone who's still having trouble with it.